Today we are continuing more with our ideas on natural log. So we are doing 3.4 here. Let's see here, 3.4 logs and exponents today. So let's work on some more examples. Okay, so let's say we had log of x minus the log of 20 equals, say, 0. Well, here, as we know, the log of x and the log of 20, they are an expanded form. So the first thing we want to do is we want to combine them together. So here we know it's a subtraction, so it has to be a division. So it's x divided by 20 is actually 0. And since I didn't write a base, right, every single time if there isn't a base written, we can always assume the base is going to be 10. So what this is basically saying is 10 to the 0 power, like 10 to the 0 power equals x divided by 20. This, we can logic this out really well, right? Because we know what 10 to the 0 power. Anything to any 0 power is going to be 1. So we can solve this quite simply, then multiply both sides by 20. So x must then be 20. Let's try another example now. What if we had e to the x, e to our power of the x over 1 over 8. A little reminder, the natural log and e are inverses of each other. So if we took the natural log of e to, let's say, 3, this is going to equal 3. Likewise, if we took e to the natural log of, let's say, 4, the answer is going to be 4. They kind of cancel each other out because they are inverses of each other. So knowing that, I'm just going to take the natural log of e to the x equals the natural log of 1 over 8. Well, that cancels out the e. This gives me an x, and then this gives me the natural log. X must then be the natural log of 1/8. If I punch that into my calculator, x equals negative 2.079. Let's do another example using the log. We had now the log of x. We'll say this equals negative 2. Once again, there isn't a base, so we can always say this is going to be base of 10. So let's say we rewrite this in exponential form. We have 10 to the negative 2 must then equal x. Well, all we have to do now is punch that into our calculator, and that should give us what, 0.01 equals x. What if we were given something that doesn't have a base of 10? Let's say we have log of 3 of x equals 1/2. Well, now I know this is, we wrote it in exponential form, 3 to the 1/2, right? 3 to the power of 1/2 must then equal x. Well, that's not bad. We can just take 3 to the power of 1/2 in our calculator. That's the square root of 3. We punch it in, round it up to 3 decimal places. We got 1.732 must then equal x. Continuing with more of our examples, say we have 3e to the x equals 65. Well, I know that my natural log will get rid of that e, but first we have to isolate the e. So the first things I'm going to do is I'm going to divide both sides by 3. E to the x is then 65 divided by, I don't think 65 divide well by 3, so I'm just going to leave it like that. I'm going to take the natural log of both sides, so the natural log of e to the x equals the natural log of 65 over 3. X then must equal the natural log of 65 over 3. And you can punch that into your calculator. And we get X then must equal 3.076 rounded. Let's try a little bit more of a complex problem. Let's say we have here 5 to the x plus 8 equals 47. How do we solve these? Well, the one thing I always want to try to do is I want to isolate my x. So first things first, I'm going to subtract 8 from both sides. That gives me 39. And now I can see there's 5 to the x. Well, I know if I took the log of both sides here, because what you do to one side, you have to do to both sides. So if I took the log to one side and the other side, I can rewrite the first side as x times the log of 5 equals the log of 39. Oh, here we go. Now we can isolate this x. I can just divide both sides by the log of 5. And that should give me my answer of 2.276. Same thought process can be applied to equations with an e. So if it's, say, we have 700e to the negative 5x equals 175. Well, first things first, I want to isolate my x as much as possible. I'm going to divide both sides by 700. So then that's e to the negative 5x equals, I'm going to leave that number kind of alone. For now, I guess I could simplify it. It simplifies into 1/4. That will make our ending calculations easier. Like before, as I said, the natural log and the e cancel each other out. So if I took the natural log of both sides, so natural log of e to negative 5x equals the natural log of 1/4. Well, the e cancels out, so we get negative 5x must then equal the natural log of 1/4. Divide both sides by negative 5 to finally solve for our answer. So we just got to punch that into the calculator. Natural log of 1/4 divided by negative 5. And I get x equals 0.277 as an answer. Let's try a different type of continuing more on our examples. Well, let's say we have e to 2x minus 9e to the x plus 20 equals 0. And this is now a little bit more complex. But I notice e to the 2 and e to the 1. Isn't that kind of like a quadratic? So I can factor this. I can factor our quadratics. So here, if I factor this, and I would factor it just normally if I would factor a quadratic, 2 factors of 20 that add up to make negative 9. Well, isn't that negative 4 and negative 5? So e to the x minus 4, e to the x minus 5. That factors well. One answer has to be an e to the x must equal 4, and e to the x must equal 5. To find our x's, we just take the natural log of each side. That gives me x must equal the natural log of 4, x must equal the natural log of 5. Punch those into our calculators, and we get 1.386 and 1.609. And as we can see, there are many different types of examples that we could use to solve for this. Let's do one last example, variations of this. So let's say we have the log of 4x minus the log of 2 plus the square root of x equals 2. What we know is we can condense this. right? So we can say this means the same as the log of 4x divided by 2 plus the square root of x must then equal 2. And what else we can say? Well, we already know that there's no base written down, so we can technically say this is a 10, right? Base of 10, we already say this. So if we wrote it in exponential form, I know it has to be 4 over 2 plus the square root of x must equal 10 squared. Well, now we got rid of all the log. We can just solve this. 4x divided by 2 plus the square root of x equals 100. We can multiply both sides by 2 plus the square root of x just to get rid of that fraction. I'm not a fan of fractions, so let's do that. So the other side becomes what? 200 plus 100 root x. I'm going to just move everything to one side. We have now 4x minus 100 root x minus 200 equal 0. If you don't recognize this yet, we currently have a quadratic on our hands. So here we can just simply factor this if it is factorable. Let me see if I can. I'm going to divide everything by 4 first. So this gives me 25 root x minus 50 equals 0. It does not seem to factor well. I can't think of any factors of 50 that's going to subtract to make 25. So what I'm going to have to do is, I know this is a quadratic. Since this doesn't factor well and it is a quadratic, I need to put it into the quadratic equation. But however, the quadratic equation only works with the quadratic form. So I'm going to move my x's by themselves, and I'm going to square everything to get my quadratic form. So I'm going to move this, going to keep to one side, and I'm going to move the other part, the 25 square root of x, to by itself because I want to square everything. So first I'm going to square one side, square the other side. This gives me now x squared minus 100x plus 2500 equals 625x. So now I have a set of numbers that I could put into my quadratic formula. Subtract 625 to both sides. We got 725x plus 2500 equal 0. If I put that into my quadratic formula, we should get x equals 3.465 and or x equals 721.535. Remember our original equation, we have here we have the square root of x. This means that both answers won't work. One of them is going to be extraneous, and in this case the smaller one we know is going to be extraneous just because in this terms we want the bigger, the positive one, because if you have a smaller one it's going to be more likely that under here it's going to be a negative. So we want our bigger positive number, and that is our answer to our equation.